Alright, welcome to another section of this class. Now we're going to be looking at how to differentiate trig functions. That is the definition of trig functions. Trig is the abbreviation for trigonometry. Trigonometry. We have so many trigonometric functions. We have examples of them are cos x, sin x, tan x, and so on. We have cosec x, sec x, cot x, and whatever. So although the major two trig functions we have are the sin x and cos x. Tan x is sin x divided by cos x. If you divide sin x by cos x, you will have tan x. And the others like sec x is the inverse of cos x. Cosec x is the inverse of sin x, while cot x is the inverse of tan x. But this is just it's good to start from here. Now this is another table for differentiating trig functions, just as we did for polynomial function in our last class. So if y is equal to cos x and x tan x, then cos of a function of x. Now this one is a type of this three, I see 1, 2, 3, is a differentiation technique that we call function of a function. We call it function of a function. So this one is still taking us to something that has to do with function of a what? Of a function. But these are the major three trig functions we have. These are just function of a trig function in which you mixed another function or the same functions together that cannot be separated easily. You cannot separate them. They are compositely combined with each other. We call them composite function or function of a function. Before you can solve them, you're going to use what we call chain rule in calculus. But chain rule is somehow cumbersome when the function of a function is now getting more complex. For example, if you have like 3 or 4 functions combined together compositely, in which you cannot separate them from each other. So if you say if you want to use chain for that, it might be cumbersome or hard to resolve. But if you use this trick I'm about to show you now for solving function of a function in trig function, you might get the what's it called? The answer in few minutes or few seconds anyway. So the first one is if you differentiate cos x, you're going to have minus sin x. Differentiate sin x, you're going to have cos x. Differentiate tan x, you're going to have sec square x. Now if you differentiate cos of a function of x, that is cos mixed with another function of x, you're going to have minus the f prime of that x. That means when you differentiate this function of x, you're going to have f prime of s. It means differentiate this function you are seeing here to have this. Then differentiate cos, you have minus sin. Then you repeat the function of x back. The same thing with this. Differentiate this function of x, you have f prime of s, means differentiation of a function of x. Then differentiate sin, you're going to have cos. Then you repeat the function of x back. I'm going to show you what I'm saying there. So this same thing here, differentiate this function of x, you're going to have f prime of x. Differentiate tan, you're going to have sec square x. Differentiating, okay, you don't need to differentiate the function of x again, you don't repeat the function of x back. For example, let's say we have if y equals to sin 7x. I want to find the differential coefficient. Differentiation of this will just be equal to, now 7x is a polynomial function, sin is a trig function. We have polynomial function mixed with this trig function that we cannot separate them. It's not possible. It's called a composite function. So if you want to resolve that issue now, I'm going to follow this rule in which you first of all differentiate the function in front of the trig to get an answer. So remember the first class we did, differentiate ax, you're going to have a. So differentiate 7x, you're going to have 7. That's what you're going to have. Differentiate 7x, you have 7. Differentiate sine, you're going to have cos. Then you repeat the 7x back. That is the answer without any further delay. So it's as simple as that. So let's use the same trick for this. dy over dx for this will be, now we have cos of another function. This is a polynomial function or this is a trig function combined together in form of a composite function. So differentiating 3x, you have 3. Differentiating 9, you have 0. No, so that is minus 0. That's why we will have differentiate this from side. Differentiating this cos, you have minus sine, then you repeat the function of s back. So that the final answer will be minus 2 sine 3x minus 9. So that's what we're going to have in that one. So that will be the answer to that question. So for this, we're going to have the verb at the s will be equal to differentiating sine x, because we have tan and sine s. And these are two trig functions combined together, which you cannot separate. You cannot separate them from each other. It's a composite function. And you can also only use chain rule to not get your chain rule directly without putting any complex equations or complex formulas. Just follow this method. Differentiating this last, the function that is combined with the trig. So this trig is combined with this trig now. So differentiating this first one, is sine s, we're going to have cos x. Now differentiate this one now. Differentiate tan s, we're going to have sec square. Then you repeat this function back that's in front of the sine. So that's how you do that. Probably the answer to that. So this is the answer to this. The answer to this is the answer to this other one. So let me give you one or a few ones to solve. Let's say we have, let's say number 4. If y is equals to, let's say I'm having cos of sine x. Cos of sine x. If you differentiate this one, you're going to be having minus cos x sine x. That's what we're going to be having. That's what we're going to have. To try and see if we can get it, we're going to be having minus cos x sine x. So number 5, also try this. If y is equals to let's say tan 4x minus 9. You have for this, we're going to be having 4 sec squared 4x minus 9. Let's say number 6, we're having something like if y is equals to, let's say, sine exponential x. Yes, we are having if y is equals to sine exponential x. Although we are not on the exponential function, I'm going to show you how to differentiate the exponential function. Now, differentiate this one, we're going to have having differentiate exponential x. The thing will still be exponential x, it will not change. So differentiating exponential x is still remains the same. Then differentiating sine, we have cos exponential x. So now let me answer to that. So you try and see if you can resolve this using those explanations. You get the answer. So God bless you all. See you guys in our next class. If you have any question, you can put it in our comments. Ensure you share this video, share it to those that need it, and subscribe to this channel so that you'll be receiving more wonderful and helpful videos from us. God bless you all. See you guys in our next class.